Thank you so much for joining this lesson. Today we're going to discuss the Kenya National Mathematics Guru Examination Council, Mathematics Paper 1, Section 1. Later, we shall be uploading the Section 2 of this wonderful paper. So stay tuned. Remember to subscribe. Remember to share so that you may invite a friend to this wonderful lesson. Number 1 in Section 1, without using a mathematical table or calculator, evaluate the square root of a quarter minus 2 out of 9 raised to power 2, then plus 1 out of 4, the third root of 64, or rather the cube root of 64. So let us attempt this one together without using calculators, without using the 4-figure tables. One thing that you're supposed to understand, we can see a root and a power. The second root and also power 2. So we are taking square root after squaring. That means the step shall be cancelled. Those who are used to indices, you know very well, it's like we are being told a quarter less 2 out of 9 power half. That is the meaning of square root. Then after raising to power half, we raise again to power 2. After square rooting, now we square again. So these powers are cancelling. That is what it means. So the expression is now to power 1. And it becomes 1 out of 4, 2 out of 9. So we have sorted out the first part of this expression. Remember, there is plus. So we can complete the part by taking the LCM of 4 and 9, which is 36. 36 divided by 4 gives us 9 times 1, 9 minus 36 divided by 9 gives us 4. 4 times 2 becomes 8. So this is 1 out of 36. What about the other part? Then now we shall be combining the two. So the other part now, this other part is having 1 out of 4 multiplied by the third root of 64. You see, instead of 64, we can have it as 4 times 4 times 4 after expressing 64 to base 4, because we have to find the third root. And you discover now 1 is out of 4 multiplied by, when we are finding the third root, we just pick out of these 4s, because there are 3, we pick only 1. And you discover that the third root of 64 is 4. Therefore, this is now 1 out of 16. Now we can combine the two sides by the addition sign, which is between the two sides. So this now shall be 1 out of 36 plus 1 out of 16. Again, we're going to use the LCM to add the 2. Allow me use the LCM, which is 144. Is it 144 or 72? I think 144. 72 is not divisible by 16. Yeah. So 144. 144 divided by 36 gives us 4. So we shall be having 4 times 1, which is just 4. Then plus 144 divided by 16. This gives us 9 times 1. We get 9. So this is 13 out of 144. 144. So this is now the answer. It is in the simplest form possible. So that is the final answer for number 1. Together we proceed to number 2. Mr. Ogara, a part-time teacher in your school, is paid at a constant hourly rate. Now, after working for 8.5 hours in the month of January, he earned 6,000 120 Kenya shillings. In the month of February, your school increased the hourly rate in the ratio of 6:5. Calculate the amount he will earn if he worked for 5 2/3 of hours in the month of February. Okay, so we are supposed to first understand the working rate of Mr. Oigara, whereby we shall say 8.5 hours or 8.5 hours in the month of January attracted 6120 Kenya shillings, meaning that per hour, in 1 hour, he is going to earn 6120 out of the total hours that he had worked, so that we may know the working rate per hour. Therefore, per hour it shall be 6120 out of 8.5. We get 720 Kenya shillings. So this guy is being paid 720 Kenya shillings per hour. Now, this amount is getting increased now. The hourly rate is getting increased to a new rate. So what is the new rate per hour? The new rates for Mr. Agara is going to be the original multiplied by the increasing ratio, 6/5. You know what it means? When it is an increasing ratio, you multiply such that, okay, you make the ratio a fraction, but in such a way that the bigger proportion is the numerator because we are increasing. So by 6/5, this takes us to 864 per month, or per hour, sorry, 864 per hour. But now, this guy shall work for 15 hours and 2/3 in the month of February. Therefore, total earning for the month of Feb shall be 15 and 2/3 hours, each hour earning 864. This shall attract how much? Let us check. We multiply this by 15 and 2/3. This is giving me 13,536 Kenya shillings. So this is the amount that Mr. Ogara is going to earn for the month of Feb for working for 15 hours and 2/3. That's a very good question on rates and proportions together with ratios. Number 3, which is a question on, indices. Okay, 4 power x minus 5 into 2 power x then plus 4 equals to 0. We are solving for x in this indices equation. Guys, remember to subscribe. Remember also to share so that you may invite a friend to the powerful lesson. Shifting Grades is the home of academics, and everybody deserves the benefits of watching us. Remember, apart from these presentations, guys, we have interactive sessions. Over every holiday, we invite you to our classes. Whether you are in senior school, whether you are in junior school, please reach out. Our number is already attached on the screen. Look at the bottom right on our poster here, 0704 15 3366. You can just reach out so that you get in touch with us, so that you may know what happens in our platforms. Remember also, even if you are in junior school, the timetable is independent and you are all invited. The grade 7, grade 8, grade 9, then grade 10s, form 3s and form 4s. Whether you're preparing for KCSE, whether you're preparing for the KCSE, we got you covered. So kindly book an appointment with us. Remember, in the month of August, ladies and gentlemen, we're going to bring on board examiners in NEC for KCSE and also for the KCSE. so that you may be taught on what to expect, the structures of every paper, and also the marking techniques in every paper. All the fine details about every paper, we're going to get them just before term 3. Then we submit you to the hands of NEC for evaluation when you are well equipped. So kindly book a date with us, enroll for our serious interactive programs. 0704, I repeat, 153366. Number 3. Okay, we can see power x is in 2 terms here. There is power x here, there is power x. One is a base 4, the other one is a base 2. So 4 can be expressed to base 2 because we know that 4 equals to 2 power 2. But now there is an existing power of x. So this shall be 2 power 2. Then there is the existing power of x like that, minus 5 and 2 to the power of x. This plus 4 shall be equal to 0. At this point now, we can see that, this can be written as 2 power x and now raised to power 2. 5, 2 power x, then plus 4 equals to 0. You can see 2 power x is appearing twice. So can we let 2 power x to be a different unknown? Let's say t. Yeah, let's solve for t, guys. So we will have t squared minus 5, then t now appears again there, then plus 4, this is equal to 0. This is a quadratic equation showing up. It's now becoming quadratic. So let's solve the quadratic equation. So we say that we can use any of the formula. I prefer we can use the factorization method, whereby we need a product of a times c. A is the coefficient of t squared, which is 1, and times c. C is the constant, which is a 4. So that's 4. Then sum the value of b, which is the coefficient of t. That is a negative 5. At this point now, the factors shall be a negative 1 and a negative 4. Their product is positive 4, and the sum is negative 5. So instead of, in the equation now, instead of negative 5t, we can have negative 1 and negative 4t. So t squared minus t minus 4t. So we have splitted the negative 5 into negative 1 and negative 4, then plus 4. This is equivalent to 0. From the first two here, we factor out t, then we remain with the t minus 1. And in the other two here, we can factor out a negative 4, so that we remain with t, and a negative 1. This is all equal to 0. At this point, can we now talk about from inside the brackets, we have t minus 1, and outside the brackets, we have t and a negative 4. This is equivalent to 0. So now each of the factors here can be equated to 0. T minus 1 equals to 0. T minus 1 equals to 0. Or t minus 4 equals to 0. Either of them or both are equal to 0 because their product equals to 0. So t from the first one equals to 1, and also t equals to 4. So we have two possible values of t. But now, what had we let to be t, ladies and gentlemen? What had we let to be t? That is we get back to this stage, this one. We had let 2 to the power of x to be t. So 2 power x equals to either 1 or 2 power x equals to 4. Now, in each case, we can express the right hand side to the base of 2, such that now we can equate the powers. Do you remember we have several laws of indices, but now there is this law that we call the zero index. With the zero index, we say that any number raised to 0 gives us 1. Anything power 0 equals to 1. Meaning that from the first expression, or from the first equation here, 2 power x equals to, instead of 1, 2 power 0, because anything power 0 equals to 1. And this will take us to the value of x being equal to 0. We equate the powers like that. Or from the second equation here, 2 power x equals to, instead of 4, 2 power 2. And therefore, the value of x is equal to 2. You just equate the powers because the bases are already the same. So we have 2 possible values of x, either 0 or a positive 2. A very good question, interesting for that matter. Number 4, solve the inequality x power 2 minus 5x less than 6 and state the integral values satisfying the inequality. This is a quadratic inequality. Yeah? We're supposed to be very careful, not an equation, inequality. So x raised to the power of 2 minus 5x, then minus 6 less than 0. We remain with a 0 like that. So it's quadratic in nature. Let's factorize. Let us factorize so that we may solve for the values of x that satisfy this particular inequality. So from the right hand side, from the left, sorry, we need a product -6 and a sum of -5. Do we have sat? Let's check. What if we talk about -6 and a +1? Product shall be -6 and sum shall be -5, yeah? So x power 2 minus 5x, sorry, instead of -5, we are now substituting with -6x and a +1x like that, then -6 less than a 0 like that. So we're having from the first two, this is the factorization which we've just applied in a previous question, x minus 6, then +1 x minus 6 less than a 0. X minus 6, then outside the brackets x plus less than a 0. At this point now, ladies and gentlemen, we may say that in case this was an equal sign, then we would have gotten the values of x. The values of x as the values of x that we are getting are, let me take it slowly there, x minus 6 equals to 0 on its own. Or x plus 1 equals to 0. So this is x equals to 6, or x equals to -1. And therefore, because on the inequality, we are not having these. We're not having or equal to. The two limits of x that we are getting are not part of the integrals. The two limits that we are getting are not part of the integral values of x. And therefore, we are saying that the values of x now shall be from -1 to 6. In between, the values in between -1 and 6. So they shall be 0, 1, 2, 3, 4, and 5. So 6 cannot be included, and -1 cannot be included because of how strict the inequality symbol is. So we have those integral values satisfying the inequality. Number 5, ladies and gentlemen. Now, Mr. Ndaye received 360 exercise books and 288 pens for distribution to students. If each student must receive the same number of exercise books and the same number of pens, all without a remainder, determine the greatest number of students who can receive the items. So we need a number that can divide 360 and also 288 without a remainder. And that means we need the greatest common divisor, the number that can divide without a remainder commonly, both 300. You know, there are very many numbers that can divide 360 without a remainder. There are other numbers that can divide 288 without a remainder. But in this case, ladies and gentlemen, we strictly want the number that can divide both of them and without a remainder. And that is our greatest common divisor. So the greatest common divisor, famously known as the GCD, or the highest common divisor, can now be determined. 360, 288. We start by dividing by the least prime factor, which is at 2, giving us 180 and 144. I think that is well divided. They are still even numbers, so 2 can proceed to give us 90 and 72, still even. So we proceed with 2 again to give us 45. And is it 36? Yeah. Now 36 is even, but 45 is not. And therefore, 2 cannot continue dividing them. Can we proceed to 3, ladies and gentlemen, to get 15 and to get 12? What about by 3 again to give us 5 and 4? You see, 5 is already prime, so we can't continue dividing any further. And so we will say that the GCD now is given by the shared prime factors, that is 2 times 2 times 2, then we multiply by 3 times 3. This is exactly going to be 2 by 2 by 2, that's 8. 3 by 3, that's 9. So 7 by 8 by 9 gives us 72 students. So it is 72 students. That is the maximum number of learners that can share. Maximum number of learners. There are other numbers, like when we take the first 2 common factors, 2 by 2, that is 4. 4 students can divide equally without a remainder. When we take 2 by 2 by 2, that's 8. 8 students can still divide. When we take 2 by 2 by 2, then by 3, you know that will give us 24, right? Yeah. So 24 can still divide. But now the maximum is the GCD. A very good question. Number 6, ladies and gentlemen, simplify x power 2 minus 3xy plus 2y power 2 divided by y power 2 minus x power 2. You know, these are quadratic expressions. The nature of the denominator is a difference of 2 squares, but I would encourage students to first simplify the numerator on its own and later the denominator on its own, then combine the simplified forms of each. So getting into this, we start with the numerator, whereby because of its quadratic nature, we need a product of a by c. So 1 by 2, 2, and a sum of the value at b, the coefficient of xy, which is a -3. What are these factors? if not -1 and -2, multiplied +2, added -3. So now we're talking about x power 2 minus xy minus 2xy, then plus 2y power 2. From the first two terms, we factor out x. So that will remain with x minus y, then minus 2y in the other two, and we remain with x plus, no, x minus y. Yeah, x minus y. Whatever is in the first bracket should recur in the second. So inside the brackets, what are we having? X minus y. What about outside the brackets? X minus 2y. Then we check the denominator. Now at the denominator, it's a difference of 2 squares. Y power 2, x power 2. So y power 2 minus x power 2. This shall simplify to give us y minus x and y plus x. That is how a difference of 2 squares is usually factorized. You can prove by expanding my right-hand side. You get y power 2. That's a general quadratic identity. So from this, we can now combine. From the numerator, we add x minus y. From the denominator, x. Okay, we have x to y. Then from the denominator, we having y minus x and y plus x. Is that okay? Thank you. So at the numerator and also the denominator, we can multiply by -1. Yeah, let's multiply by -1. When you multiply both sides by -1, just look at this. We multiply both sides by -1. Or can I make it simple? Yeah, by -1 and also by -1. When we were doing the paper 2 section 1, I think there is something that we used the same, multiplying by -1. We use the same principle. When we multiply by -1, you shall discover that the -1 can remain here at the numerator. Please check carefully. X minus 2y. Then out of. Now -1, when it multiplies the denominator, we choose to multiply the first factor, whereby it's y minus x. So when you multiply by negative, the y shall bear negative, but negative x now turns to positive. So that x now is the one that is positive, but y turns to negative, like that. So the negative has affected the first term at the denominator, meaning that now this and this one are common. So we have our -1 and x minus 2y out of y plus x. So we are done the simplification. Nothing else is common. Fully factorized. Number 7. Number 7, let's read it together. 2 radii of a circle of radius 14 centimeters subtend an angle of 90 at the center. A straight wire is stretched between the 2 points on the circumference to form a chord. Calculate part A, the length of the arc between the 2 points, and part B, the length of the chord, leaving your answer in third form, or rather in the form A root B. Allow me sketch this particular information. You know, there are some of the concepts in math, actually most of the concepts in math are made simpler by diagram sketching. Some concepts, become halfway simpler than how they are when sketched. So we have a quarter of a circle here because I can see the angle subtended is 90, the center. So that is a quadrant, a quarter of a circle. So the circle is like this. Now we am fixing the arc. Aha, like that. So 90 like that. So when we talk about the arc now, AB, from A to B, it's a portion of the circle. Therefore, we need beta over 360. I'll start by giving the formula 2 pi r. Therefore, we substitute beta over 360, 2 pi r, like that. What do we get here? Now, this is a quarter. 90 over 360 times 2 times 2 over 7 multiplied by 14, giving us exactly double 2. I hope that is properly multiplied and without any error. Part B, the length of the chord, leaving your answer in sad form. So the chord shall now connect A to B directly. Yeah, like that. Remember, we already have 14 is the radius, and also 14 is the radius. So when we talk about this chord now, then I will have to talk about Pythagoras theorem. So I need 14 squared. I add 14 squared. Then I take the square root. Yeah, I think Pythagoras theorem shall really help us. Okay, so allow me use my calculator there. 14 squared plus 14 squared. This gives us the square root of 390. 392. To give it in sad form, to give this one in sad form, what shall it be? Let's check. Now, inside the 392, let me check. When I divide it by 2, I'm getting 196. Yeah, so 196 is a perfect square, or it's a rational number. 196 by 2, like that. You know, a sad should be in its simplest form. Therefore, 196 is a rational number, and it can be worked out. Square root of 196 times the square root of 2. Therefore, this is 14, and the square root of 2 is irrational. So that is the length in sad form, centimeters. Just like that. Yeah. Just like that. A very good question. A very good question. The length of an arc, also the length of a chord, together with a review on SADs. Are we checking number 8 now together? Yes, number 8 together. As we get to number 8, ladies and gentlemen, be reminded of our mode here, the mode that we use to purchase airtime for all the networks. As long as you are operating in Kenya, in the borders of Kenya, within the borders of Kenya, Airtel, Telcom, Safaricom, kindly just go to your M-Pesa, Lipa na M-Pesa. Then the pay bill number is 737356. A very easy pay bill number to master. This is a number you should master, and you transit it to your friends so that they may also master. Then from there, you enter the account as the phone number that you're purchasing the airtime for. After which, you proceed with your transaction. You enter the amount that you'd like to spend as airtime. Then you complete your transaction. You receive the airtime instantly. Remember, you can also purchase the airtime for a friend, whereby you use the same pay bill, then the account number is the phone number of the friend that you'd like to receive the airtime. You can surprise a friend, a family friend, a peer friend, a church friend, or whichever friend that you have. Purchase an airtime for them. Please purchase for them, for yourself, and for family. Then after that, now we shall continue growing together. Looking at number 8 now, a water tank is fitted with a 40 digital flow meter that overrecords the amount of water pumped by 0.4 liters every hour. 0.4 liters every hour. The meter was reset to 0 at 7 a.m. Then at 4:30 p.m. on the same day, the meter shows that 5,200 liters of water have been pumped. Determine the actual amount of water pumped by that time. So in this portion of 5,200 liters, some is a wrong recording, but that wrong recording per hour is known according to this particular meter. So we can say this because per hour we know the over recording. Then we can check the total between this time it's operating. 4:30 in the 12-hour clock system, but in the 24-hour clock system, it becomes 16:30 hours. All the way from 7, we're going to get 30 on the minute side when we subtract, and 9 on the hour side. Meaning this 9 hours, 30 minutes is half. So 9.5 hours of operation. In every hour, there is 0.4 liters. What about in 9.5? So we multiply this by 0.4 liters of every hour so that we may know in the 9.5 hours, how much liters. This is 3.8 liters. That is the over recording now. So now actual recording. So the actual pumping, the actual capacity of the pumped water shall be 5200 minus 3.8 liters. You know, when you subtract now 5200, 3.8, we are getting 5,196.2 liters of water. So that is the amount in liters which has been pumped in the specified duration. A very good question. Checking at number 9 now. In number 9, we are told, using a pair of compasses and a ruler, construct a parallelogram ABCD such that the line AB equals to 7 centimeters, the line AD equals to 5 centimeters, and the angle DAB equals to 75 degrees. Measure the length of the diagonal AC. Simply to sketch, first we can sketch this particular with AB, 7. Then which angle? The angle at A is the one to be 75. So 75 shall be here. So that now another 75 is also here. So we use the length from A to D is 5. So 5 to D. So we also measure another 5 here because it's a parallelogram, meaning that opposite sides are equal and parallel, like that. So we are constructing an angle of 75 at point A. It's good to make a sketch. A sketch will enable you to visualize the information. Allow me start by doing a very straight line and then mark off at one point at A. Then using an arc of exactly 7 centimeters to allow me identify a point on the same line and have it as my B. I've used 7 centimeters of length. Then now we need to construct exactly 75 degrees at point. And remember, please, a normal paper will always have some basic construction and geometry. So please be equipped. So I begin by constructing exactly 90 degrees. So I raise a perpendicular at point A. I raise a perpendicular at point A. By standing at A, I make an arc. Just standing at A, we make an arc and we also make an arc. Then I use the same radius or slightly longer radius than that to stand on the arcs now. Standing on this arc, I make an arc, and standing on the other arc, I cut the first arc. Then through this now, I can produce some 90. You can produce some 90 degrees there. So that's a perpendicular bisector at point A, or a perpendicular line, 90 degrees. Then now, standing at point A again, I construct 60. Remember, we've been told to use a ruler and a compass. That means measuring angles with a protractor is not allowed for this question. So we stand at point A, we make an arc, then we stand on the arc at the line, and we cut the same arc on the upper side using the same radius. Then now we join it to point A. That will be exactly 60. Now with exactly 60 degrees like that, allow me now say that for us to achieve our angle of 70, you see now between the angle of 60 and that of 90, there is 30 degrees that remains there. Therefore, when I bisect the 30 degrees here, when I bisect the 30 degrees there, I'm going to get my 15, such that 15 plus 60. This is 60. So I need 15 to make my 70. How will I achieve 15? I bisect the 30 between perpendicular and 60. So standing at A, I make an arc across like that. Then standing on the arcs at the lines, I make an arc. Standing here, I also make an arc. So now I can produce a bold line showing the bisection of 15, which is automatically, this is 15. So I now have 75 automatically like that. So along this line now, for me to see part D, I have to measure exactly 5 centimeters. Exactly 5 centimeters. That is D. Then this is 5 centimeters. Now to proceed with this, it becomes very easy for us. Do you know why it is very easy? It's because the major construction has been done. All the major constructions have been done. So what we need to do now is to use a radius of 5 centimeters, and we stand at point B with 5 centimeters. We make an arc here. Then we use 7 centimeters and we stand at D. And again, standing at D using 7, we make an arc like that. Then now the arc becomes our point C. It is 7 centimeters from D. It is 5 centimeters from B. So the intersection of that arc now becomes our C. So that's point C. Can be confirmed by joining the arcs now. Yeah, like that. So we have point C identified. You can also get point C by constructing another 75 on the outer side here. you construct a 75 there, then you produce the line, and after producing the line, you mark on it 5 centimeters. And after marking on it 5 centimeters, now you join the 5 centimeter mark to point D, and you'll have gotten your parallelogram. Now with that, after the construction, we proceed to measure the length of AC, which is a diagonal. You don't actually need to show the diagonal. You don't need to construct it. You don't need to show it. It's here. Let me show those who don't know a diagonal, but it is here. That's a diagonal. So now we measure this one. You use your divider to stand at point A, stand to open it to C. And after opening it like that, now you transfer it to your ruler. When you transfer it to your ruler, you shall confirm that AC is exactly 9.6 centimeters. We mark this allowing an error of plus or minus 0.1. So the people with 9.7, the people with 9.5 are always considered to be within the range, and their mark is assured. Yeah, exactly 9.6. I've also confirmed using my ruler. It's exactly 9.6. So that is the diagram that you are needed to come up with. We are now looking at number 10, a very good question here, a trade about an item for X Kenya shillings. Then you first increase its price by 30% and then later reduced it by 10%. If you finally sold the item at 3,510, making a profit of 510 Kenya shillings, calculate the percentage profit made by the trader. How do we get percentage profit? We need the profit itself out of the buying price expressed as a percentage, that is multiplying by 100. So we have the profit as 510 Kenya shillings. Then do we have the buying price? We have the selling price. He sold it this, and this is the profit. Meaning that when we take 35.10 and we subtract 5.10, we shall get exactly 3,000. Yeah, exactly 3,000. So he had bought it at 3,000. That is why after selling at 3,510, there is a profit margin of 510. Very simple. So now percentage profit then shall be profit out of buying price expressed as a percentage. Let me compute these. 510 times 100 out of 3,000. This is exactly 17%. So that is the percentage profit. Number 11, guys. This is a question on statistics. Statistics 1. The table 1 below shows the frequency distribution table of masses of 96 students in a Form 4 class. We have the masses there in kilograms, then we have the frequencies, the number of students in every class. Now, using the table 1 above, complete by drawing the histogram below for the remaining set of data. How do we draw a histogram? First, when the classes are uniform, we simply plot frequency against the what you call the class boundaries. Frequency on the vertical axis, class boundaries on the x-axis. That is when the classes are uniform in length. But in this case, you can see some classes are bigger than others. So we don't have uniformity. And that is why when you look at what the examiners already tried to plot is frequency density against the masses, which is also the boundaries. So what we're supposed to know is that frequency density is given by frequency out of the respective class width. So frequency density should be calculated first, whereby in the first case, we need a class width of, okay, 8 out of a class width of 10. So 0 0.8. In the next case, 18 out of interval 15 from 40 to 55. So that is 1.2. In the next, it is 12 out of from 55 to 65, 10. So 1.2. In the other one, it's 18 divided by from 65 to 75, that's 10. So 1.8. 1.8, right? Then 20 is the frequency divided by interval from 75 to 95. That is exactly 20. So 20 over 20, we get 1.0. In the next case, from 120, okay, all the way to 120 from 95, that is 25. So 20 over 25, we get 0 0.8. So we have now the respective frequency densities. When class intervals are not uniform, we plot frequency density against the against the boundaries of every class for us to get the bars, which is the respective histograms. You can see there is an error in this. We should be having this line exactly here. So that you have 30, 40. I'm trying to establish the scale that has been used. Just give me some time to establish the scale on the x-axis. So on the x-axis, let's identify the scale that has been used by the examiner. The scale is, you see, from 30 to 60. What are we having there? 1, 2, 3, 4. We have 4 squares representing 30 units, meaning that 1 square shall represent 30 out of 4, which is 7.5. 7.5 kgs. So every small square is equal to 7.5 according to the scale on the x-axis. Yes, according to the scale on the x-axis. From 30 to 60, that is 30 kilograms, and they have been represented by 4 centimeters. So each centimeter is representing 7.5. I hope that is now clear. If that is clear, then we can check. We can check the small squares now inside. One small square. If 5 small squares represent 7.5, what about one small square? It shall be 7.5 out of 5. This is exactly 1.5 kgs. So one small square is representing 1.5. And now we want to move. Let me check now. I don't know what I was correcting there. Let's look now at the diagram keenly and say, for us to move from 30 to 40, that is 10 units. So 10 units and 10 units, or rather 10 kg. If one very small square represents, look at this relation here. We have established that on the x-axis, one small square is representing 1.5 kg. Then what shall represent the 10 kg in the first class, which is given there? So we need we need to say this is a 10. Yeah. One small square is 1.5. What about 10 kilograms? So we need 10 divided by 1.5, which is approximately 6.5 or 6.7 classes. We need 6.7 small squares. And that is why you can see the examiner is having the class running all the way to after 5 small squares. Actually, we are supposed to move all the way to the 6th division. The 6th division, then point something. The 6th point something like that. So it should be running all the way to after 6 squares. We also move an extra distance like that. Yeah. 6 plus or 6.7 like that. Then now we check. What about the vertical axis? You can see from 0 to 1, how many divisions are there? From 0 to 1, how many divisions are there? On the y-axis again, let us identify the scale that has been used. On the y-axis, we are talking about 1, 2, 3, 4. Now 4 centimeters. Okay, which may mean 20 because in every centimeter we have 5 small. So 20 small squares are representing 1 unit. What about 1 small square? What does it represent? Look at this. Look at this crazy scale. We have 0.05 people, of course, because now that is the frequency plotted there. Okay, frequency density, so it's units. Yeah, it's units. 0.05 units. The very small square represents 0.5 units, just as you can see. So now in the first one, we need 0.8. So how many small squares do we need? 0.05, we multiply by 0.8. Or rather we say, look at this. We are talking of one small square or 0.05 units being represented by one small square. What about 0.8 units? This will be 1 times 0.8 out of 0.05. So 0.8 divided by 0.05. This is giving us 16 units. So we need 16 units on the vertical axis. 16 small units. So 5, 10, 15, 16. So that one has been properly drawn. Yeah. 16 units on the vertical axis to represent the 0.8 units. Then the next now, I've taken good time to interpret the two scales for you. It's good for you to know this. On the vertical, one small division. On the horizontal, one small division. Then once you've interpreted or analyzed the scale, it becomes very easy for you to. So we need now to say, for the second class, we are moving now from 40 all the way to 55. That means we are adding 15 units. So 15 units, how many for 15 units? How many small squares do we need? We said 1.5 kg is being represented by one small square. What about the 15 that we need? The 15 kg now. We need 1 times 1 over 1 times 15 over 1.5. So 15 over 1.5. This is giving us 10. So we need 10 small squares. So from where we are, we add 10 small divisions. So 1, 2, 3, 8, 9, 10. Yeah, we were adding exactly. We've added exactly 10. Look at that counting. There's already half here. So we are talking of the 3 that we have here, 8, and 2 more. So instead of adding the 2 more, we add half because there was half that was not counted there. What about upwards? So we shall move up to that point. But what about upwards? Upwards now, we need 1.2 units. 1.2 units. And we said 0.05 requires one small square. What about 1.2? So it will be 1.2 over 0.05. Yeah, 1.2 over 0.05. We need 24 units upwards. So upwards, we need 24 units. So we have 5, 10, 15, 20, 24 up to that point. 24 small divisions. Like that. We complete our bar. We complete. It's now done. We move to the next. The next class is moving all the way from 55 to 65. That is 10 divisions. And upwards, it's the same. So 10 divisions. 10 divisions will be represented by, like in the first class, 6 point something units. So the point something is here. So we add 6 complete units. 1, 2, 3, then other 3. Yeah, other 3 up to this point. And we raise up to the same height, 1.2. 1.2 will require 24 units upwards. I hope you see those frequency densities that are equal. Yeah, the frequency densities are equal. The frequency densities are equal, 1.2, 1.2. Then we go to another frequency density of 1.8. So 1.8 divided by 0.05. That gives us 36 units upwards. 36 units upwards. So we count 36 upwards. This is a 25, 30, 35, so 36 shall be here. So we'll be raising up to 36. Up to 36 like that. Then now, horizontally, again 10, meaning 6 point. So we are already having 2 here. We add 4 and some portion. 4 and some portion. Like that. Height 36 of them. 36 small squares. I hope that one is well visible. That way. Let us check the other class, ladies and gentlemen. We have 1.0. So it should be 1.0 and we divide by 0 point. For the vertical, we said 0.05. 20. So we need 20 upwards. 20 upwards means, yeah, 1 is already here, actually. 1 is already indicated. The frequency density of 1 is already indicated, yeah? It's here. What about the interval from 75 to 95, which is 20? We take 20 and we divide by 1.5. This is 13.3. 13.3. So the point is already here. So we add 13 of them. 5, 10, and 3 others up to that point. We raise up to height of 1. Let me tell you, choice of scale is a very technical. You know, there is choice of scale and there is interpreting of scale. Are we now in the last? Vertically, 0.8 should be divided by 0.05 to give us 16 units. So 16 units, just like in the first class, yeah, 16 units. So we are raising up to this point. We're raising up to that point. What about horizontally? We are moving up to where? From all the way to 120 from 95. Guys, we have 25. So we divide 25 horizontally by 1.5. This gives us 16.66, 16.7. So we are already having the point. Okay, we are not having the point, so we move 16.7. So these are 2, 7, 12. We add 4 points. 4 point. So we shall be at this point. That way. The shading of the bars is not a mandatory. You may or may not. So you must not shed. You may shed when you have time. You may not shed. And so when you are in rush, you're doing paper 1, you've not even selected your best questions in section 2, you cannot start shading at such a case. Looking at number 12 now, we are told that on a Monday, but before we read this question about a Monday, let's get back to this graph and say, just a reminder, when class intervals are different, calculate frequency density. How do we calculate frequency density? Frequency out of width of a class. Then you plot frequency density against the class boundaries. Yeah, the class boundaries like that. Then when the intervals are uniform, like 10, 10, 10 throughout, you just plot the frequency the way it is and the class boundaries. Frequency on the vertical axis, class boundaries on the horizontal, like that. Then another graph which features in paper 1 is the frequency polygon. So for the frequency polygon, you plot frequencies against the midpoints of every class. Frequency against midpoint to give you frequency polygon. Then you connect the coordinates using very straight lines. Number 12. On a Monday, a car traveled from Kisii to a town known as Singapore at an average speed of 80 kilometers per hour. Okay, so a bus can move from Kisii to Singapore. Let's continue and see the miracles being performed here by the set of the question. On Tuesday, the car traveled back to Nairobi at an average speed. At an average speed that was 25 kilometers less than the one from Nairobi to Singapore. Calculate the distance between Nairobi and Singapore. That is a confusion. We should be having Nairobi at this point then. So in the first day, that was a Monday, a car is traveling from Nairobi to Singapore, 80 kilometers per hour. Then now, on Tuesday, the car is traveling back to Nairobi at an average speed that was 25 less than the one from Nairobi to Singapore. Calculate the distance between Nairobi and Singapore. So there is something here I want you to understand. You know, I'm trying to read the mind of this setter. Yeah, the mind of the setter. When the speed is 25 less, you know, the first speed, the Monday speed, the Monday speed is equal to 80 kilometers per hour. What about the Tuesday speed? This is Monday. The Tuesday speed shall be 80 and we subtract 25. A speed of 55 kilometers per hour. Yeah. Then there is some missing information here. Kindly allow me read the statement that is missing. I find it in the marking scheme. We are told that on Tuesday, the car traveled back to Nairobi at an average speed that was 25 kilometers less than the one from Nairobi to Singapore, and took 45 minutes more. Yeah. And took 45 minutes more. So on the return journey, there is 45 minutes more being taken because of course it has now reduced the speed. Then calculate the distance between Nairobi and Singapore. It is now understood. Now we can proceed. There was that missing communication. So we are now saying these are two different speeds. There is a certain distance somewhere. So how do we get, because speed is given by distance out of time. Now, how do we find time? Time as an expression now be given by distance out of speed. So Monday time as an expression, we can call it, Monday time as an expression shall be the distance out of the speed of 80. What about the Tuesday time? The time taken on Tuesday. The Tuesday time shall be the same distance, but now out of a speed of 85. Now, what we are being told is that the time taken on Tuesday is more by the time taken on Monday by 45 minutes, because when the speed was less, it is when more time is taken. So this time of D out of 55, when we subtract D out of 80, we should get 45 minutes. 45 minutes is 3/4 of an hour. Yeah, 3/4 of an hour. So with this now, we can solve. We can now solve. So let's solve for the value of D now. This is an equation. Can solve for the value of D. So 1 out of 55 minus 1 out of 80. This is 1 out of 176 D, 3/4. That's a very technical step. You know, these are like terms. It's D and D, so you can subtract directly. Now, to get the value of D, ladies and gentlemen, I'm supposed to multiply both sides by 176. So 3/4 by 176. And this takes me to 132. The examiner should explain to us why the distance between Nairobi and Singapore is only 132 kilometers. Nairobi and Singapore. Okay. Number 13, triangle PQR as vertices P 2, -1, Q 5, 3, and R 1, 4. Triangle P prime, Q prime, R prime is the image of PQR under translation vector T. Now, given that the image of P is P prime 7, 2, find the coordinates of P prime and Q prime. There should be additional statements under the same translation. Okay, it has been said so. All right. Yeah, the whole triangle has been transformed. So now we will say this, when we take a translation vector and we add object, we usually get the image. So the translation vector can be let to be xy. It is two-dimensional, of course, plus the first object, that is of the object of P, which is 2, -1. This should take us to the image of P, which is 7 and 2. So how can we get x? Using the x components, x plus 2 equals to 7. So to remain with x, we subtract 2 from 7. That gives us 5. How do we get the value of y? Y minus 1, that's a negative, plus negative, y minus 1 equals to 2, meaning that to remain with y, we add -1. We add 1 to the other side, or we take negative to the other side, making it a positive. So the translation vector is 5, 3. That is the translation vector. Now, with the translation vector already established, let us talk about now the coordinates of every other. And this should not be P, it should be R prime and Q prime, because we are already having P. So R, we start with Q. For Q, we say translation vector plus the column vector of Q, which is also 5, 3. You know, this is giving us 10, 6, meaning that Q prime is going to be 10, 6. What about the same translation vector when we add it to R, 1, 4? This is going to be 6, 7, meaning that R prime is 6, 7. We write it as a coordinate like that. You don't introduce the equal sign. You just write a coordinate by introducing brackets after writing the name of the coordinate. Number 14, ladies and gentlemen, number 14. The figure below represents a cone. You can see a cone. Draw the net of the cone. One thing that you're supposed to know is that a cone is just a folded sector. And if it's a closed cone with another surface, then we introduce the circular part. So we'll say that for the curved part, it can be opened out to a sector. We open it out to a sector like that. So this is a sector. When you fold a sector of a circle, you get a curved part of a cone. Please try that one at home. Then now, we should be having a circle here for the bottom surface, which is circular. This is circle, such that the circumference of the circle equals to the arc length, because it equals to, let's say that is arc AB, to mean the circle will have a circumference. It will have a circumference which is equal to arc AB, so that when you fold the sector, the arc AB becomes the circular part. So it should be closed by a circle, which is having a circumference equal to the arc. I hope the net is properly sketched. Looking at number 15, I hope we are together here. I hope we are together in number as we transit to number 15. Now in the figure below, point M divides PR in the ratio 1:1. 1:1, meaning that M is the midpoint of PR. Please understand that. Then PQ 7.2 is already indicated. QPM equals to 72 degrees. That's an angle already indicated. PQM 41 is indicated. Now we calculate to 1 dp the length of QM. So for QM, to allow us use the sine rule, whereby we have capital letters for angles and we have small letters for the opposite sides, such that for the triangle PQM, we can all say that the length P, which is our QM and unknown, out of the sine of the angle at P should be equal to, we can now pick an angle which is known. You see 41 and 72 are known. So when you add the two, then you subtract from 180, we shall get 67. So when we pick the length opposite to 67, 7.2 out of the sine of 67. Okay, we would have used the expression first. So we pick the length small letter m and we divide by sine of the angle at m. The ratios are supposed to be the same. So P is unknown out of sine of the angle at P, which is 72. This is equal to M. The length M is 7.2 out of sine of the angle at M, which we have concluded that it is 6.7. So to remain with P, ladies and gentlemen, now it should be 7.2 sine 72 out of the sine of 67. So I've cross multiplied by sine 72 both sides. So 7.2 sine 72 divided by the sine of 67. I'm getting 7.438. 7.438 to 1 dp, 7.4. So the length is sorted, 7.4. This is 7.4. Like that. Can we proceed? Yes. We need the length of QR. QR is there. Okay. It's good for us to know that this angle shall be equal to, when we take 180, because it's along a straight line, and we subtract 67, we get 113. So let's know that as we continue working out our things. Now, can we work out the length PM first? We can use now for that one, we can use either cosine rule or sine rule, because in this particular triangle, the first one, EQM, we have all the two sides and all the angles are known, meaning that finding the missing one is very easy. So you can see the length PM, which will be called small letter q in this case. Small letter q over the sine of the angle at Q, which is 41, is equal to, for that particular triangle, we can use 7.2 and 67. 7.2 out of the sine of 67. So how do we remain with the length Q? If it is not by taking 7.2 We multiply by sine 41, then we divide by sine 67. This shall be 5.132. 5.132. 5.132. So the length of this part is 5.132. 5.132. And something else that you're supposed to know, according to the instructions prior given, then the other length of M to R is also 5.132. So now we can think broadly and use either the first triangle. Look at the first triangle. Okay, the bigger triangle, PQR, and the two lengths. Check the length PQ is known, and the PR can now be found. Then now we will have the angle at P known, but the opposite length to P is not known. Meaning that using the original triangle, you see PR, the length PR shall now be equal to 5.13 times 2, and this shall be 10.26. 10.26 centimeters, yeah? 10.26 centimeters. So using the original triangle, let us apply the cosine rule. So for the first triangle, for the bigger triangle, cosine rule, allow me start by stating it. When I take P squared, which is the known length, opposite. P squared is the opposite of, if P is here, then the length, which is small letter p, is this one. P squared should be equal to, when we take R squared, we add the other length, which is also Q, which is Q squared. Then we subtract 2 times R times Q, the cosine of the angle at P, which is now a capital like that. That is the statement of the cosine rule with reference to the triangle that we are having. So P squared unknown equals to R squared. So R, the angle is here, at the opposite length is now 7.2 squared plus Q squared. Q is here, so the opposite length to Q is 10.26 squared minus 2 multiplied by 7.2 times 10.26. Then everything here again, cosine of the angle at P. The angle at P is 72. So cosine of 72. P squared equals to, let me work out now. 7.2 squared. I add 10.26 also squared. This is giving me 157.1076. I subtract 2 multiplied by 7.2 times 10.26 cos 72. I'm getting 45 here. Then 0.655. P squared equals to 157.1076 minus 45 point. So I'm getting 111.4522, such a thing. So P shall be now the square root of this value, which is 10.557. What about the instruction of 1 dp? It was overall for the whole question. So 1 dp, 1 decimal point, 10.6 centimeters now becomes the length QR, which is our P. The length QR is 10.6. Yeah, 10.6 that way. Then number 16, we are finally wrapping up the section 1. Finally, we are wrapping up the section 1. I request you to continue subscribing, continue sharing, to invite friends. Line L1, passing through points A, negative 1, 4, and point B, xy, has a gradient of negative 3 out of 2. I'm checking another correction there. Coordinates of B are 3y. Coordinates of B are 3, y. The gradient is given there. Find the equation of another line, L2, which is perpendicular to L1 and passes through point B, leaving your answer in the form ax plus by plus c equals to 0. Okay, let's check this. You know, we have the gradient for the first line, and we are having coordinate A given, but the coordinate B is given partially. We know that the value of the gradient is given by change in y minus 4 out of change in x, 3 minus negative 1. So negative 3 over 2 equals to y minus 4 over 3 minus a negative 1, 3 plus 1, making it 4. Like that. We are interested in the value of y. So can we talk about cross multiplication in this case, where we shall have negative 12 being equal to, because negative 3 multiplies 4, 2y minus 8. Then to remain with 2y here, now we have to make the negative 8 positive, minus 12 plus 8, making it a negative 4. What about the value of y? It will be negative 2 after dividing through. Therefore, the coordinate B is now 3, negative 2. It can be fully described now. So we have the coordinate of B. After getting the coordinate of B, now we ask ourselves, if we have the first gradient of line 1 and it's perpendicular to a line 2, you remember that gradient 1 times gradient 2 should give us negative 1 if the two lines are perpendicular. Therefore, negative 3 over 2 multiplied by a known gradient 2 should give us negative 1. To remain with gradient 2, we have to multiply negative 1 by 2 over negative 3. The negative shall cancel after multiplication, and the second gradient is confirmed to be 2 over 3. So if we have the second gradient for the line 2, and now we are talking about its equation, then we have been told that it passes through coordinate B. Then we shall talk about the gradient being expressed using coordinate B and another coordinate xy, a general coordinate. So y minus a negative 2. You see coordinates of B is here. So it's minus a negative, making it positive. X minus the value of x, which is a 3. So now look at the format in which we need the equation. X comes first. So we cross multiply in such a way that we start with x. So this shall be 2x minus 3 equals to 3y plus 2. So 2x minus 6 equals to 3y plus 6. Can we now order the form of the equation to suit what has been mentioned there? 2x comes first, then negative 3y comes next, because when 3y comes to the left, it shall be negative. Then we are already having negative 6. Now we subtract again 6 to give us negative 12, so that we remain with a 0 on this side. So that is the last question in the section 1 properly worked out. Thank you for following us. You can support our programs, if you don't mind, using the till number which is on the screen. Any amount shall go a long way. You can choose to stand with our programs by sending your support through the till number 497772. See you next time. Thank you for following us.